Hi folks, I'm going to do a little recap video today covering some of the images that have been recorded of the comet sighting spring encounter of Mars, both by amateurs and professionals. Now, some people are noticing what they see as weird stuff going on in those images, and Suspicious Observers kind of covers all the major aspects that are currently being talked about. So I want to set straight some of the misconceptions about those images, so let's see what he has to say here.
Good morning, folks. Let's go right to a sighting spring update. NASA's first pictures are in, and they are highly disappointing. With all the technology and all the satellites watching, I am dubious that this is the best they got. No more amateur footage has been published, and we're left with some interesting conclusions. First, there was definitely light effects of the camera, some lens flaring, and Mars' version of a sundog. But if that's all that happened, why cut the live feed? Highly suspicious. Now, it must be noted that it was not NASA or the ESA's feed, so comments saying that they cut it off are blatantly incorrect, as they had nothing to do with those feeds. But still, why were they cut off? No good explanation exists as of now, but we can say this. Yesterday we remarked that if a background star was flashing during this sequence, then it was a light effect and nothing special at all. After some careful examination and speaking with an expert, this may not truly be a background star flaring and an artifact of whatever happened on Mars itself, meaning that even a background flash like this one could be caused by something real happening at Mars. Is this enough to make a conclusive call? Certainly not, but with the privately controlled feeds being cut off and the official images underwhelming, how can one not speculate? Right now, here is what we can say. The companies in charge of the live feed cut it out upon occurrence of the anomaly. It wasn't NASA, but that's not the point. There are definitely a few videos out there making a stink about simple light effects. However, that initial conclusion about the background star may be incorrect. The expert photos are borderline pitiful given their technology, and we cannot completely rule out an electrostatic discharge between bodies. Updates to come as needed. Jumping.
Okay, so first I want to address the professional images. And at this point, I kind of get to say I told you so a little bit, because during my webcast on Saturday night, which a lot of people came to, and I hope you all enjoyed it as much as I did presenting it, I specifically talked about the professional images before they came out, and I warned people not to be expecting the images to blow them away in terms of quality. And that's because the cameras involved were not purpose-built for astrophotography, believe it or not. They were built to capture short exposures of bright daylit objects. Curiosity, Opportunity, MRO, all of those probes were designed with cameras for short exposures. Now, it's true that Curiosity uses the exact same type of CCD sensor that's in my telescope's camera. But my telescope's camera was entirely built for astrophotography. All the electronics around the CCD are just as important as the CCD itself. It's designed to actively cool the CCD to prevent the buildup of thermal noise. The electronics are designed so that they won't induce any electronic noise in the CCD for a long exposure, and it's a very big, clunky device. Curiosity, a couple things. Mass is a premium, even though it's a fairly big rover. You still want to save on mass wherever possible because you want to use it for instruments, more and more instruments. And space is another consideration too. And so these instruments were not built with astrophotography in mind. And so I warned people about that. So here are my comments from Saturday night.
To think about that, but in any case, hopefully we get some good images out of it. But I wouldn't hold your breath on stunning, spectacular images where you're expecting to see huge coma and tail all across the Martian sky, because Curiosity's camera is not really designed to do astrophotography. They're going to try their best, but it wasn't built with that in mind. It was built to do shorter exposures of the daylit Martian surface and rocks and everything else. So I don't know what the noise profile is really going to look like. Even though it's the exact same type of CCD, there's a lot more to it than just the
Okay, so if you want to see the rest of what I had to say, you can go check out the video on my channel. It's still up and available as the replay from the webcast, Mars and Comet Sighting Spring Live. So now I want to talk a little bit about some of the amateur images that were discussed. First up here are images from Dr. Fritz Hemmerich. BP Earthwatch also presented these images. And you can see something happening there with Mars. And Suspicious Observers tries to suggest that maybe the fact that it's also happening to this background star here isn't important. Well, it is. It's affecting all the stars in the image, so it's not something going on with Mars. It's something going on with the image. And it's a cloud. I immediately recognize that because I've got experience with this sort of thing with astrophotography. And this is what happens when cloud cover starts coming over during long exposure deep space astrophotography, especially when you got something really bright in the field of view and it's shining through the clouds and producing these nice effects there. But so is the star. The same effects are occurring with the star. And you can actually see it come into the field of view. If you watch on the right side of the screen, you'll see it start to dim the stars on the right side before the left side. See, it's coming across there. That's what's happening. And you don't have to just take my word for it. The guy who actually recorded these images has posted a comment on one of the Facebook groups where some of us observers are gathering and exchanging images. It's a private Facebook group for observers of comet sighting spring. And here's what he had to say. The burst is affected through some very fast-moving clouds, which altered the exposure of some of the 75 shots. The quote-unquote plasma burst exists only in the insane brains of a certain kind of people who wish to have some events and proofs for their theories. He didn't hold any punches or pull any punches on that, but you get the idea. You don't just have to take my word for it. The guy who took the pictures is saying they're clouds, and he would know because he was the one there taking the pictures, and that's all it was. So now as to the other images, the images from the SLU webcast, if we go back here just so you can see it again from Suspicious Observer's clip of it. So it starts off here with a nice yellowish, orangish Mars, and then suddenly, what is that? So some people are seizing on that and saying that Mars was suddenly having some sort of electrical or plasma interaction with the comet. But I recognize that too. That's quite common from repositioning the telescope during exposure. Well, the camera they're using there is probably taking exposures constantly. It looks like it's possibly a Malin cam or some other video camera, which is just constantly running exposures. And when you move the telescope, when you reposition the telescope during exposure, that's what happens. I've had that actually happen on my webcast too. This is a webcast I did back before Justin TV banned me for webcasting from my telescope. That's a whole nother story. But anyway, I've got it saved on my YouTube channel here. It's Deep Space 119, 2012, Part 3. And at 1:56 and 29 seconds into the video, you could see here's Mars. This is actually Mars in infrared light. That's why the color is different like that. That's just how this camera responds to infrared light. And then just a moment later, I reposition Mars in the telescope. And boom, we see this. Same exact thing, just in a different direction because the orientation of the camera is different. But it's the exact same thing. And notice you don't see it with the stars. Well, how can that be? Well, the stars are much dimmer than Mars. And because it's moved towards the end of the exposure rather than towards the beginning, it just ended up that way. And as a result, the stars aren't bright enough to produce a detectable signal in their new position on the CCD. Mars, being very, very bright, is. And so you see it streaking around even if you can't see the streaks in the stars themselves. So you see the exact same thing here where the stars all look solid, but they're actually not. They've actually been moved too, but they're too faint to produce a detectable signal by the time the exposure ends. So if you continue to watch it, you'll see that Mars moves in the image as they reposition the telescope, and it forms this sort of two-ball shape. And the same thing happened with my video. If you continue to watch it, you'll see the same sort of thing. That's just how it goes sometimes when you're repositioning the telescope. And that's when they cut the feed. They change to another camera, cut the feed, whatever. They're repositioning the telescope for whatever reason. Maybe they're getting ready to go on and do something else. Maybe they're trying to get Mars more out of the field of view to get a better look at the comet. I don't know exactly, but the point is it's not mysterious. They're not trying to hide something. They're just repositioning the telescope. You can see here, there's that same sort of morphology again there with that. This is just what happens when you're moving the telescope around, which is completely normal behavior during a webcast. And as they're repositioning the telescope, they're changing the feed. Put it on, another camera that's not being moved around. So that's all there is to that. And I hope that clears up a lot of the misconceptions surrounding this. And have a nice day.